Hello everyone, my name is Sumit and I welcome all of you to BISP Self-Learning Video Broadcast Solution. This is my next video in Python tutorial for beginners and the topic is Numpy array. So let's understand what is Numpy and then we'll see how to use Numpy array in Python. Basically Numpy is an open source extension module for Python. This module provides the fast pre-compiled functions for numerical routines. It also adds support to Python for large multi-dimensional array and matrices. Besides, it also supplied a large library of higher-level mathematical functions to operate on these arrays. So as you know that we have lists and collections in arrays, but the working of list and the working of arrays is little bit different. And so we'll be going to work on arrays by using Numpy array in Python. So this Numpy array package provides basic routines for manipulating large arrays and matrices of numeric data. It also provides the functionality with a substantial collection of useful algorithms like minimization, Fourier transformation, regression, and other applied mathematical techniques. So let's see how to create a Numpy array in Python. But before creating a Numpy array in Python, first of all, we need to install this Numpy array module in our Python directory. So to set up Numpy on our system, we need to open command, and in command you need to write pip install Numpy, and it will start downloading Numpy, and it will look for the library Numpy array, and it will set up Numpy on your desktop. And once it is configured successfully, so as you can see, I am getting a message, it's already satisfied, uses upgrade to upgrade Numpy, so it's already installed. And if you want to see whether Numpy has been installed on your system or not, so you can go to the specified location, C drive, Python, lib and site packages. So look for that, C drive, Python 27, lib and site packages, and here we can see Numpy. So it has already been successfully installed on my system. Now I'm going to create programs for this Numpy. Let's see the various functions and let's see how to create a single dimensional multi-dimensional array in Python by using Numpy. So for this I'm going to launch IDLE, and here you can simply write import Numpy just to verify that Numpy has been imported successfully on your desktop system or not. So it has already been imported successfully. Now to create array, I'm going to create a new file here, and in this file we'll be going to write our code. So first of all, I write here import, and I write here numpy as np, and I write here to create a single dimensional array, a is equal to np dot array, and the single dimensional array, the 1, 2, 30, 40, 10, and so that's the array. We can test it whether it's any error or not. So I'll simply save it and save in the same directory, array tutorial 1. So as you can see here, there is no error. It means the Numpy directory has successfully installed and the array is successfully created. But now I would like to display the array. To show the array, I simply write print and a, and it will display the values of the array. And as you know, the array is the index of this array. This will be 0, this will be 1, like we have in list. So 2, 3, and this will be 4. Although the length of this array is 5, but the index range will be between 0 to 4. If I would like to print the shape of the array, shape is basically it will print the shape, or it will return the size of the array. So I write here print, and I write a dot shape. So shape of the array is 5. 5 means the length of the array, so it has got 5 elements, and 5 commas, it means it's a single dimensional array, because we can have multi-dimensional array in Python by using Numpy. And if I would like to specify, this command will print the complete array, but if I want to print only a specific element, let's suppose I want to print only 30, so here I will write print a, an index number of 30. Index number of this will be 0, 1, 2. Index number will be 2, and when I run this, it will give us 30. So this is how we can work array, how we can display array. If you want to create a multi-dimensional array in Python, so we can create a multi-dimensional array. So to create a multi-dimensional array, we need to change this. So I'll change this, and let's see how to create a multi-dimensional array. And the multi-dimensional array, I want to create a size of 3 by 3, 3 by 3. And you know, in multi-dimensional array, we can have the values data in the x and y, and the zero index number will be 0, 1, 2, 0, 1, 2, and we can have values into each and every cell. We can have values in the cell, and then if we want to display a specific value, we need to use the cell index number. Okay, it will be go row and column. It will go like this. So let's create a multi-dimensional array. It will be a 3-dimensional array. So I write here 10, 30, 40. 10, 30, 40. This is one dimension. This is one row. This is data of first row. And then I want the data of second row. 100, 500, 20. This is data of second row. Third row 60, 70, 29. And bracket close and curly bracket close. And if we close it, I'll just print it, so you can see it displayed in the exact style, exact format. Okay, and here if I want to print the value of a specific index, let's suppose I want to print 100, 500. So to print this 500, this index number is 0, this number is 1, this is 2, this is 0, this is 1, this is 2, this is 0, this is 1, this is 2. So index number of this will be, you need to count like this, 1 is to 1. So right here, print a row number 1 and column number 1 and run it. So we'll get the value 500 here. Now we have a few commands which we can use with NumPy. For example, if I use np.zeros and 2, 2, so it will create a 2-dimensional array of 2 rows and 2 columns, and zeros mean the default values of the default value in that array will be in the value of all the cells will be 0. So when I execute it, you can see we have got 0, 0, 0, 0, and the value in the float format, it will be float. So either we can specify the data type of an array, or we can directly use this. So if we do not specify any data type, it will always use with the float data. In 2-dimensional array, it will always go with the float one. So we have got this 0. If I want all ones, so here I write ones, and when I execute it, you can see all the values is ones. If I want all the cell contain the same value, so I write here full, 7. So it will create a 2-dimensional array of 2 rows and 2 columns with this value 7. If I change this to 12 and execute it, it will fill all the value with the 12. And here, instead of full, if I write I, and here I write 2, 2, so it will create a 2-dimensional array of 2 rows and 2 columns, but it will fill the values only in the diagonal cells. So sorry, not 2, 2, it should be 2, and run it. Just right. So you can see we have got the values here in the diagonal in this value 1, 1, 0, 0. So this is the use of the I. You don't have to give the square brackets and all. That was the error. So this is how we can use the I to print to save the data in the cell in the diagonal cells. If you want to create an array with random numbers, so we have a function here random, and I write here random, and the array size will be 2 by 2, and we can have random number. We should have random.random, and when I save it, we'll get this 2-dimensional array with 2 rows and 2 columns filled with random numbers. Let's create an array, a single-dimensional array here. So I'm going to create one single-dimensional array, np.array, and a single-dimensional array with 1, 2, 5, 8, 34, 65, 12, and I want this is to print the complete whole array, so it will print basically print array. And if you want to print the array from only from this to this, so we can have a slice function here. We can use slicing. So I write here print, and instead of write print, if I write here colon 2. Colon 2 means it will start from the index from 0, and it will end at the less than 2. Less than 2 means it will print start from 0 and 1. It will give us output 1 and 2. 1 and 2. It will not give 5 because this index number is 2. So the range will be 0 to 1 and less than 2. So this is basically the upper range. If I want to print the length of this array, I think I have closed it, so let me open it again. I want to print the length of the array, so I write here print len is comma length of a. So this function can be used to print the length of an array, to print the length. So we can use shape as well, or we can use length as well. This is a dot d type. Basically this d type is used to print the data type of an array. So when I execute it, I'll get an error message that the data type of array is d type int32. So the values in this array, the stored data, the values of the array in this their data type is int32. Next, let's do one thing. Let's create a two-dimensional array here. So I would like to create a two-dimensional array, and two-dimensional array will be 10, 40, 20. We need to create this. Then 100, 30, 20, 9, and 90. And we have a command. We can use print a to print the array. We can print the array. It's a two-dimensional array. But we have one more command. We can use iteration in arrays to print the in values of an array, the cell values of an array. So I write here for x in a, and I simply write here print x. So when I execute this, you can see the output, and the output will be same in the same format the data has been stored, in which we have stored the data, in which the data we have stored. So this is how we can use the iteration in an array. There are basic operations in an array like sum, product, minimum, maximum. If I want to find out the sum of an array, the sum of all the cells of an array, so I write here print sum of a and execute it. So that's the sum of array in row wise. You can see it's basically column wise sum. This is column wise sum. So if I write here sum of, as I write here sum of a, so it will give us these row wise sum, column wise sum. We have 100 plus 10 plus 100 plus 90, 40 plus 30 plus 56, 20 plus 29 plus 87. But if I want the sum of all the cells, then I'll change this command, and instead of sum of a, I simply write a dot sum, and when I execute it, we'll get the total sum of all the cells of this array, 462. Same if I would like the product of this array, so I write here print a dot prod. This will be the product. That's the product, because it's higher range, it's in the higher end, that's why we are getting this. It's out of the limit. Okay. Next we have got the, if I want to know the minimum, so I write here a dot min, and we have got this minimum value. That's the minimum value of an array, cell value. And if you want to find out the maximum, we can use here maximum function. Maximum is 100. So like this we can use various functions. And if I would like to sort this array, we have this array, and I would like, let's suppose we have got a single dimensional array instead of multi-dimensional. I create a single dimensional array. I remove this, and I create a single dimensional array here, 22, 45, 65, 34, 21, 90, 67. This is a single dimensional array. and I'll just execute this first of all. So we'll get this array. Now I want to sort this array, so we can sort this array. So how to sort this? We write here print and sorted A. You can see the array has been sorted, and there is one more function, and that function is, we can use this function, or another function is we can use a dot sort and print A. So you can see the output is same, only the difference is here we have got a comma after that, so it treats like an different index, and it treats like a proper array. So this is how we can print we can sort the arrays. Let's suppose if in this array we have got values, or the cells values are repeating. Let's suppose 34, we have got 90, 67, 2, comma 45, comma 90, comma 67, 90, comma 67, comma 21, comma 2. So if I simply print this array, so you can see we have got the array, but I won't like to print only the numbers once, or the unique numbers. I want to print the unique numbers. So here I can write b is equal to np dot unique. Right here b is equal to np dot unique a, and print b. When I print this, in this b it will get the numbers which, if any number occur 2 times or more than 1 times, it gets that number and is stored in this b array only once. So when I execute this, you can see the difference. We have got 2, 21, 34, 45, 67, 90, and the array has been automatically sorted as well. So the unique function here, this will sort the array, as well as it will read the numbers or the elements only once. So these are the various operations in NumPy array. In next tutorial, we'll be see how we can create more complicated programs using NumPy arrays, how we can work on it. That's all in this tutorial. If you have any queries, you can visit our website www.bisptrainings.com, or you can subscribe our YouTube channel for more videos on Python. You can connect with us for the customized training on Python. I will be coming up with some new videos on Python, mainly for beginners. Till then, have a nice day ahead. Goodbye.